Hi, everybody, and welcome to 5-1 probability distributions. Key concepts. In this section, we're going to introduce the concept of a random variable and the concept of probability distribution. Then we're going to illustrate how a probability histogram is a graph that visually depicts a probability distribution. We show how to find the important parameters of mean, standard deviation, and variance for a probability distribution. And then, most importantly, we describe how to determine whether an outcome is significantly high or significantly low. The basic concepts. What is a random variable? A random variable is a variable typically represented by x that has a single numeric value. Here's the important things: a single numeric value. And then the probability distribution is a description that gives the probability for each value of a random variable. We can express it as a table, formulas, which we've seen and not really used much of, or a graph. Let's talk about the difference between discrete and continuous. What does discrete mean? It means that I can actually count them. If I was counting chairs, I could say, I have 1 chair, I have 2 chairs, I have 3 chairs, but I can keep counting as long as I have chairs. And each chair is 1 away from the next. It is discrete because each value is separate from the others. Let's say I have a box, and in this box, I have 10 balls. Each one of those balls has a number on it, 1 through 10. What's the probability of picking ball number 1? If x equals 1, my probability of picking the ball that has a 1 on it is 1 over 10, because I have 10 balls. What's the probability of picking a ball that has a 2 on it? Is also 1/10. And all the way down to the probability of picking a ball with a 10 on it is also 1/10. They have an equal chance. They're all the same size. These are discrete values. I can't pick 1.1. I can only pick 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A discrete random variable has a collection of values that is finite or countable. Well, 10 is finite, and I can count them. If there are infinitely many values, the number of values is countable if it is possible to count them individually, such as the number of tosses of a coin before getting heads. For example, if I were to draw this graph, let's call this P of x, and let's call this x. The probability of getting a 1 is 1/10. The probability of getting a 2 is also 1/10, and so on. Can I connect those dots? No, because there's no possibility of getting a 1.5. I can't put a value in between 1 and 2. That's what makes this discrete. Discrete has distinct values. What is something that is continuous? What's the probability of a man being 6 feet 1 inch tall? The chance that someone's exactly 6 feet 1 inch tall is very, very small. Maybe they're 6 feet 1 inch and 1/100th of an inch tall, right? That's a possibility. When I graph this, we'll call this height, and we can call this the probability of x. And this is going to look like my bell curve. The mean value of the height of a man is 5 feet 10 inches tall. 6.1 or more is out here. If we want to know the height of someone who's exactly 6'1" tall, it's probably really small. But a better way to say this, what's the probability of someone being between 6 feet tall to 6'2" tall? That it would include 6.1 as well. Now we actually have two values. Let's say this is 6 feet here, 6'2" here, and the probability of someone being between 6 feet and 6'2" is the area under this curve. This is 6 feet, and this is 6 feet 2 inches. If we could find the area of that, we would know the probability. Let's read this. A continuous random variable has infinitely many values, and the collection of values is not countable. Because how would I know exactly how tall somebody is? If I could really measure them down to the 1/1,000,000th of an inch, well, then probably no one would be the same exact height. But we do have a range. I'm still going to say between 6 foot and 6'2", but I would write it as the probability that 6 foot is less than or equal to X, which is less than or equal to 6 feet 2 inches. So that still is between 6 feet and 6'2" and includes both sides. It includes people who are exactly 6 feet tall and exactly 6 feet 2 inches tall. I can't count all the values that are between 6 feet and 6'2". I have to have a range. I can say it's the area under the curve. Possible to count the individual items because at least some of them are on a continuous scale, such as body temperature, height. When you're growing, you don't go from 4'1" to 4'2". You have to hit every single number in between. This is continuous. Notice my graph is a continuous graph. Whereas these are just dots, this is a continuous line.